Let's get oral. Let's get oral.
Hey. Welcome back to the Let's Get Oral podcast. I'm Jonathan Dornow, one of your lovely co-hosts here, and I am fortunate once again to be paired up with Camille. How are you doing, Camille?
Super great. It's sunny here. I'm happy.
Yes, it is winter and holiday vibes here in the LGO studio, and today we have a fantastic guest that we're excited to chat with. We're sitting here with Margôt Bacino. She is a graduate student at the Benioff Center of Microbiome Medicine at University of California, San Francisco. And she is doing some amazing work in the oral microbiome space and exploring its intersection with periodontal health out of Dr. Sue Lynch's lab. So welcome to the show, Margôt.
Hey, thanks for having me. Excited to talk about my research.
Yes. I think this, Camille, correct me if wrong, I think this is the first time we've hosted a grad student.
I know. This is great. I'm so excited because I think it brings us both back right into the lab and like we've never left. And I'm super excited to go over some of your research, Margaux, because it is definitely touching on all the things that both Jonathan and I are so interested in. And you're taking it, to the next level now, whereas we were, a while back. So we've come a long way since then. And I'm excited to hear your story. First, how you got into this space, because it is such a weird space to be in. Kind of give us the lay of the land, how you made the journey into, my gosh, a PhD program.
I've always been interested in science since I was little, like doing, experiments in the backyard with my brothers and, just very curious, I think.
Wait, I'm going to stop you there. What kind of experiments?
Yeah, we can't just drop without
like
details.
Mixing things and then burying them and then seeing what happens in like a week and a half. Or, I think one time I got a hold of some like measuring the pH pool chemicals. We got in trouble after that one.
Oh.
So
did you alter the pH?
No, we were just trying to, because there's like an acid. So I think we were trying to break down concrete in the backyard. I don't know what the ultimate goal was. I don't think we had one. But that wasn't a rare occurrence. That it was something that we would get into often.
Amazing.
But after growing up, I did undergrad. I just studied biology and I worked in a lab at USF, which is just across from UCSF where I'm at now. And I really got interested in doing research and just having a question and then actually using tools to get to have a question and then have an answer or kind of an answer. I really enjoyed that.
What kind of lab was that initial experience?
It was like a breast cancer research lab. I was doing very basic things, just like running PCRs, but I was so stoked on it. And then after college, I actually just got a job in a research lab at UCSF, studying in the lab of Dr. Stefan Hablitz. He's an oral guy, but from a biomaterials perspective. So our lab studied dentin, which is the inside of your teeth, and looking at remineralization and how you could kind of make a biomaterial that could remineralize rather than just completely remove and replace as caries are kind of treated. And then the other part of the lab studied the formation of enamel. So that was really cool. And I was working there for a while and, thought I wanted to go to grad school, but wasn't really sure. And a spot opened up within UCSF. There's a subset for graduate school called Oral Craniofacial Sciences, OCS. And he was like, you should apply. I think you'd be great. And I was like, okay, sure. This was right around COVID too. So it's like, what else am I doing?
Yeah, exactly.
And then how I got interested specifically in the oral microbiome is kind of a convoluted story. While I was working in that previous lab, I presented at IADR, at International Association of Dental Research, it was in Vancouver because we had a postdoc who couldn't go. So I presented on her behalf. And then you have so much free time. So I went to lots of talks. And I went to a talk, I honestly don't remember who was presenting, but it was on the oral microbiome and the use of chlorhexidine and how that can affect blood pressure. And I was just shocked and amazed. And I think that's what got me hooked. And then once so that kind of happened before, and then I got into grad school, and then I was just, looking at labs to rotate in. And I rotated with Dr. Yvonne Capilla, who studies periodontitis, but she's now at UCLA. And then I rotated in immunology lab, Dr. Tiffany Scharschmidt, who's great. She's the chair of my committee. But then I ultimately settled, obviously, in Sue's lab with our very broad microbiome studies. So kind of like a twisty, turny way, but I love where I am. And I've convinced, I would say 99% of my lab to floss more regularly. So
Amazing.
doing the work.
I love that you have both the remineralization and the periodontitis elements, because they're such vastly different phenomena that we have to follow and coordinate in oral health, and just really separate issues, but yet they somehow relate to each other in really disparate ways, that I think that we're still uncoupling. But what did your research in remineralization look like?
So we were looking at modifying different, because it's super common for fillings to fail, and then people get secondary caries, obviously, where they had primary caries. And also, I think dentistry generally, not due to dentists themselves, but just the practice is kind of something worked a while ago, and they're we're just going to keep doing that. It's also a very complicated system, I understand, but
Yes.
so my lab really was why are we, because there's a lot of even when you're measuring for periodontitis, it's all these clinical parameters of pocket depth, where it's literally crude measurements. With filling caries, they scoop out as much dentin based on the touch of the dentist who's in your mouth, which can be kind of arbitrary. There's not a good parameter. And so that the research really was modifying these biocements with an ability to remineralize by basically, so the idea was so you wouldn't have to remove as much dentin, that you could leave some of the softer dentin behind, and remineralize this stuff is called PILP, which is polymer induced liquid precursor, which basically allows the hydroxyapatite mineral to get within rather than to mineralize on the outside. Not unlike I kind of think of it like hard boiling an egg rather than just having the shell harder. So try to get the minerals deep within the dentin rather than just creating surface mineralization.
That's really cool. Do you have any insight onto how that project is progressing? Do you think it'll reach the clinic?
I mean, I hope so. I think these things take a long time, and then to do it on scale, and then you obviously have to have a partner, probably 3M or something.
Right.
But I do think that there are, Stefan's lab is not the only one. There's other ones that are studying how to improve biomaterials, which I think is super important. I think I listened to a talk a while ago, and the presenter said that the way we look at healthcare these days really just kind of ignores your head, dentistry, your eye health, your mental health, your hearing is kind of not included when we think about health. And when caries and periodontal disease are such, huge global problems that many people are facing that impact them daily, I think we need to have better solutions. So yes, I think that there's more solutions on the rise. I think it'll take time, and especially both time to, refine, and then time to implement in a way that's cost effective, because that's also obviously something dentists have to worry about.
Do you have any thoughts and opinions on current remineralization techniques? And that's primarily fluoride and hydroxyapatite.
I mean, in the lab, I did experiments using fluoride for remineralization. So I mean, I've seen it in my own hands working and working in a very
Yeah.
positive way. So
Yeah.
I'm not opposed. I think they're great ideas. I do now with, my microbiome perspective. Now I kind of shift everything the way that I think, because I think that for a long time, not just dentistry, we've focused on human health as the human and not really considered all the organisms that are living within and on us. So yes, like we know that the amounts of fluorides that are in toothpaste or in our drinking water or whatever are beneficial, completely beneficial to the human health, and not detrimental. But in terms of what may be happening to the microbes, I don't know. And I don't know if there's been enough research to look at that. Not,
Yeah.
not positive or negative. I just think it's an important factor that now we are aware of and that we should consider when, looking at human health. There's a whole other, community that we have to consider rather than our just human being. So
Yeah. I mean, I think you bring up some salient points. One being that the head is not involved. And I think that is a throwback of when we thought the soul was in the head. And so we isolated the body from the head to prioritize medical for the body. Even though now there's a lot of hyperbole about where the soul can lie. But that there are medical issues with the head too that are now involved. So yeah, it's a hard place to kind of expand into medical and bridge all of these specialties to really harmonize effective treatments. But with the fluoride aspect, I think, it was developed at a time where all bugs were bad. We had identified pathogens and became horrified, essentially. So I think, again, we're expanding our knowledge, and it's hard to get over these historical fears and thought patterns that once drove how we do science and how we do medical intervention. And so we're at kind of a crossroads again, where we're trying to expand the understanding and dialing down the fear and kind of trying to embrace some of these attributes, like the entire head and all of the bugs that are in and on us. So I think it takes a really open mind to bridge some of these issues. But I'm really I love that you have seen both sides of the remineralization and periodontal bacterial story, because it does shift your perspective on how we use our tools in a more sophisticated, targeted way. Like, I think a fluoride is a good thing too, but I also see that fluorosis is an issue and that, dose matters. So, I don't want to throw out the kitchen sink of options. But I think that we now have really great technology to target lower dose and still be really effective. But to that point, what have you seen in the oral cavity as far as the microbiome that is kind of shaping your thoughts and opinions? You did mention the nitric oxide story, but in your own hands, what are you working on? And tell us about your journey there.
So my project, I kind of have two projects that, theoretically, if both go super well, would pair up quite nicely, but they are very distinct. But the ground is that they're study periodontal disease, and kind of with the basis of, yes, we need better, more targeted treatments for periodontal disease. The treatments that we have now are just, I mean, clearly not doing it for the prevalence of the disease, for the rise of antimicrobial resistance, like things that really we need to consider, and also just flat out the cost of dental health care. Like, some people can't afford to have to come for constant cleanings, and that's a whole other issue. But if we had better tools, perhaps, people wouldn't have to come in so regularly. So my first project is focusing on looking at microbial derived products that can inhibit periodontal. We like to call them, and I think it's extremely important to not call anything a pathogen and not call anything straight up a commensal, because if you look at a lot of oral commensals, in quotations, in, you Google them and it's like, can be linked with like blood disease or something like that. So like if a bug is not where it's supposed to be, or if it's acting outside of its normal range of behaviors, then yes, it can be more pathogenic. Or if
Agreed.
it's, suppressed in some capacity, then it's a fine member of like society, to
Yeah.
use one note in the mouth.
It's not
So
binary,
anyway,
right?
yeah, yeah, exactly. And I think that that's an important distinguish. Like, I think there's been a lot more interest, like gladly, in the oral microbiome space, but then it's like, oh, if you have these bugs, 100%, this is bad news. But that's not necessarily true. It's how are they behaving and how are they impacting their closest members of the community. All that being said, I'm studying, like, my first project focuses on a consortium of Porphyromonas gingivalis, Tannerella forsythia, Treponema denticola, and Fusobacterium nucleatum.
All the
I
smelly
picked
ones.
those for this. They smell so bad, but now my whole lab knows how to identify periodontite in the ground.
Yep.
That perio breath is really a thing. I can tell you that
Oh
my
boy.
lab also smelled like perio breath. It's gross.
Yep. Yeah. My lab mates don't, and we study some, like I said, every body site, and I have the stinkiest samples by far.
For sure.
So my first project was, I took an old approach. I made a phosmid metagenomic library. Phosmids are just like very big plasmids. And then I used healthy oral DNA and made all of these like clones. So these E. coli contain a chunk of healthy oral DNA. And then I took the supernatant from these clones and then screened them. For my reference only works if you have ever played Super Smash Brothers, excuse me. But Kirby is a character that can like suck up another character, and then when it spits out that character, it's kind of like cute Kirby, but with like Donkey Kong superpowers. So that's how my project is.
I love it.
I just have 20,000 Kirbys.
Wow.
Please, when you give your dissertation, have a Kirby graphic switching from.
Oh, I have one.
Yes. Yes, I love it.
So I have my army of clones or Kirby's, and then I have taken their supernatant and screened them against this consortium of pathobionts. And then I have found some that cause inhibition of the pathobionts, and now I'm basically doing downstream analysis to figure out who are they, what are they producing. And the idea there is, again, I don't know if a perfectly targeted antibiotic-like approach where you're killing everything is the best approach. I think you just need the organisms to act how they act in health, and that doesn't necessarily mean killing them. So that's kind of my approach for my first project. And then my second project is a clinical study, just kind of observational study of looking at periodontal disease, severe periodontal disease versus health. And I am collecting longitudinal samples from periodontal patients at their initial evaluation visit, at the time of their cleaning, and then at the 6-week follow-up. And I truly am collecting as much as you can in a single visit. I am collecting saliva, I'm collecting plaque samples and oral wash samples, and then those are all stored in, I'm storing it, one of the plaque samples in DNA RNA shield, so I can do DNA RNA analysis. I'm storing another plaque sample in glycerol because maybe I want to grow them. Likewise, I'm doing that with basically so each sample type gets like split into a different kind of subcategory. So the idea there is kind of paint a better picture of what's the difference, not only between health and disease, which I think has been kind of on a broad spectrum, been pretty well characterized in the recent years with 16S sequencing, generally speaking, I think. But I think it's important to understand the differences not only between health and perio, but between two individuals with perio and an individual who recovers and someone who doesn't. So the plan is to, look at, some people call it transcriptomics, some people call it dual RNA sequencing. I think it really depends on the crowd, but basically see both from like what's going on from a what's being transcribed perspective from the RNA side, but then also using metagenomics to see who's there, and more so, a lot more specific than you can just with 16S. So,
are you going to be able to look at viruses?
I mean, so I have done some pilots in terms of, it depends on the sequencing depth, obviously, just because I'm not, currently I'm piloting, I'm really, I'm a fan of long read sequencing, which is kind of a fringe type of, I wouldn't say fringe. I would say up and coming type of sequencing, perhaps.
Emerging.
I think it's gotten yes, emerging. Yeah. I think it's gotten a bad rap in the past because of hasn't been as accurate, but the accuracy has really improved. And what I like that you're not, because it's the sequencing that I have been doing is not based on amplification, so you're not drowning out the smaller organisms. And in my pilot that I have, like one of the pilots that I've done with the sequencing, you see bacteria, you see archaea, you see viruses, you see fungus. So
Yes.
it's kind of like, more whole picture. And so, yes, short answer, yes, I would be able to see everything that's going on. But my focus really is, on the bacterial side, but not to say that also won't be there.
Are you doing host side as well?
Yeah, so I'm curious about, because I feel like there's a debate in periodontal research where some researchers think it's not infection, but more driven by the microbiology side. And then some people are like, no, strictly immunology. I think we should all just agree that it's both. And that there's
Agreed.
like a snowballing effect.
Yes.
Where you have, the immunology, the host, increased inflammation makes a much more comfortable environment for the pathogens to thrive, which makes a much more inflammatory environment for the host. And it's just a cyclic effect until you have, severe gum recession and bone loss. So, and not to mention the links with other systemic diseases. So I am looking at the host side, both in terms of when I do the transcriptomics analysis. I'm also collecting saliva and going to look at inflammatory markers.
Nice.
I'm also from the oral wash, which is like a saline sample,
Yeah.
have collected human cells. And so you can kind of see who's there basically on a very basic level. So I'm really trying to have a pretty big picture, but with tools that I don't think have been implemented enough in the oral space that have been used when we look at the gut microbiome or upper airway.
Yes.
So kind of using the tools that are familiar in my lab, but pushing it towards a field that I think they have been underused in.
That's fantastic. I appreciate your comprehensive, or dare I say ecological approach of using modern tools to assess these questions in the oral cavity, both with the hosts and the microbes in mind, obviously the bacteria, but even looking at the others and that interplay. From this research and your experience, do you feel like the current oral hygiene routines and cares that have been typically promoted is sufficient for being able to manage earlier stages of periodontitis? And if not, do you have any insights or thoughts of what adjustments or additions could be made to help prevent/mitigate the progression of such diseases?
I think that there's just not enough emphasis on periodontal health. I think even when you go to the dentist, you think of, I need to brush and I need to floss to prevent cavities. And not cavities, like we have already discussed, are a huge issue. But when you think about the organisms that are thought to be drivers of caries, and you think of the organisms and their wild systemic effects that are drivers of periodontal disease, I just don't think it's heavily considered enough in terms of what's going through people's heads when they're thinking about flossing. I just can't today. I just, so I think that there's just a need for more education on why it's important to brush and floss. if I had a magic wand, I'd probably change everyone's diets to include more fiber,
Oh my gosh,
which
yes.
would help us systemically,
Yes.
especially, you know, both from like, we know from a physical removal of biofilm perspective, um, like eating an apple is going to clean your teeth a lot better than chewing on a piece of soft candy.
Yes.
But also from like the role fiber plays so in your diet and how that could have
Hmm.
systemic benefits. So I think just more education on the reasons why someone should brush and floss, and definitely everyone should just be eating more fiber. But
I
Yeah.
just
have,
scream that from the
I just,
rooftops.
I have had one dentist say that he would like to see fiber in a toothpaste. And I thought, well, that's not where it's really behaving the best for us. So I think that, you know, making sure we educate on the bacteria that we're feeding really has a local niche. And you're speaking to systemic inflammation can drive periodontal disease and vice versa. So there's a reciprocal relationship there. And I think it gets messy. You know, when people are thinking about the microbiome, they're thinking about this giant community. Well, but it has these localized niches, right?
Mhm.
Obviously, for the three of us, we're very intimately involved with here. But I think that, you know, broadly, it can get really confusing really fast. So fiber, I would say, would be most beneficial for your gut bacteria because those are the bacteria that really know how to synthesize the fiber components and use them, right?
Yes. Right.
But it's also acting like a toothbrush down there.
Yeah. Yeah. Right. I'm assuming your dentist spear, Camille, though, because for everything you said, I completely agree. Yeah, I think it's not lost upon us that there are, I think, some missed opportunities of introducing quote unquote various forms of biotics, whether they're pre, pro, or postbiotics in toothpaste or oral care applications. Um, I think about nitrates a lot, right? And so, yes, ideally eating an apple, maybe eating beets that are higher nitrate levels would be great. But, you know, changing people's behaviors is a bit difficult these days.
Well, and with the beets versus apples, I think, you know, we all know that mechanical debriding or just the
Hmm.
physicality of eating a fibrous component in your diet manipulates the plaque that grows on your teeth. And so an apple would be an obvious choice. The nitrates and beets, if you were going to eat them raw, that would be amazing. You get a twofer. Two
For,
for
yeah,
one.
right. Yeah.
I don't know how many people in my life I could see eating a beet. I would, but I don't have a bitter receptor. I think we've been over this. I don't have a
Yes.
problem eating dirt because it just doesn't taste terrible to me.
Right.
But I think that other people may have some issues. But anyway, apple. Yeah, apple a day.
Hmm.
With your cohort of the clinical patients, I don't know if you're taking what kind of information you're taking on the person themselves. Like I assume age, gender, sex, whatever, the hygiene products by chance?
So that actually was just a discussion in uh, our recent lab meeting. I currently don't have that actually on my questionnaire. It is a very general questionnaire. It has like frequency of brushing and flossing, and then it's been a discussion like how we talked about, should I just completely try to throw in a whole food questionnaire in terms of like what everyone's consuming? And there's this balance between, obviously these people are volunteers and they're at the clinic to get their teeth cleaned and to get taken care of. So I'm trying to limit the amount of time that they need to dedicate
Yeah,
to
of
this
course.
study, as well as, you know, but getting as much information as possible. But I do think, you know, try to include the branded toothpaste or what other, you know, oral hygiene are they using, mouthwash, um, kind of question. Currently I just have like the frequency of brushing and flossing, which, I mean, I don't know how honest everyone is about the frequency of flossing. So,
I can tell you, they're not. Also, they just don't, especially for brushing, actually, when I was at Colgate, we had so many toothbrush trials. You could, read back in all the research to show that if you're actually using a toothbrush that can read, the time that they're brushing, the duration and when, you'll see that the weekends, everybody falls apart. Saturday morning is like, no, everybody forgets. I mean, not everybody, but it's a big swath. So, and even my own recollection, I'm like, oh, surely I did brush today, right? And I think we all have those like little moments of amnesia, but I would say for the most part, people don't floss, but they will brush, just maybe not on the weekends. So yeah, that's a tough one. You just get your best guess, and some of them are more honest than others. If anything, they'll say, yeah, I floss like once a week, and then you can probably scale that back to once a month and be more honest.
Yeah, people just have such an aversion to flossing. It's been my personal goal over the course of grad school to get as many people to floss as possible and to tell them why they should be flossing. All my friends will laugh at this. Um, but it's worked. I've convinced many people. Both my grandfather and my aunt and uncle are all dentists, and they love that I push the flossing message.
That's fascinating. Oh, they must be so proud. So how do you convince somebody to floss more? I want to hear the argument.
I convince them that don't just think about your mouth. You have to think about your systemic health. Periodontitis is linked with all these systemic diseases. It's been linked with Alzheimer's. It's been linked with preterm birth. It's been linked with endocarditis, rheumatoid arthritis, obesity. And so don't think about your mouth when you're flossing. Your teeth are small potatoes. Think about the rest of your body. It tends to work. There's an element of fear that I think I do instill. Am I abusing my power? Perhaps. But people are flossing, so it's like ultimate good, I think.
Do you think that people who really don't want to touch a piece of floss, do you think that water flossers are a good option?
I do. I think that they're a great option. Also, like if you have braces, or I think that there should be more discussion around like we know that periodontitis increases as you age, and there's lots of reasons for that. But I think one thing we don't really consider or don't talk enough about is like access, and like if you don't have the mobility, like flossing takes a lot of dexterity. Um,
Exactly.
and if you're thinking about older individuals or people just who are less mobile for whatever reason, I think we need to be considering other options. And there's been some research that, certain water flossers are sufficient at getting the job done. So I think we have to think about everyone and think about how we can push oral care, both brushing and flossing,
Yeah.
whether that be with a traditional toothbrush and floss, electric toothbrush, flosser, water pick, whatever.
Yeah.
I think, there's a lot of people in this world, and, not one solution will fit everyone, but I do know that you need both. You need to brush and you need to floss in whatever capacity you can.
Agreed. Yeah, I was relatively late to the water pick / water flossing game, but my goodness, I cannot deny how much more regularly I floss now because of it. It just feels good in and of itself. And to your point, I have pretty good hand-eye coordination and dexterity, but especially getting to like the back molars or whatnot, I felt like my neck's going this way. It's like I'm doing some contortionist stuff in the bathroom just to try to get the floss back in there thoroughly. And then even then, like if you tweak your hand wrong, right, then you might irritate yourself and start bleeding. Whereas the water pick has been hands down. Like I look forward to it, to say the least.
So does my daughter. My daughter loves it too. I do want to ask, so you brought up the idea that we don't want to call them pathogens in our mouth because obviously they have double duty, and I could go on all day about this. But I think everybody's heard my stance on Porphyromonas gingivalis. So I want to hear about what your favorite bacteria is and the different roles that it can play.
That's a hard one. I mean, Porphyromonas gingivalis, I call it PG. All of them have their little abbreviations. I really do love that organism only because it's can just cause so much havoc. But I like. I mean, F nucleatum is. I like it because it's kind of this, you know, are you bad? Are you good? I can be good or bad in either context. I'm just here to help. It's a bridger organism. Um, I think a lot, there's those, I'm sure you have seen them, the beautiful classy fish images by Jessica Mark Welch of the
So beautiful. Yes.
biofilms. They're just so beautiful. Whenever I put them on any presentation that I give.
Yeah, same.
Like the beautiful like hedgehog, corn cob, whatever you want to call them, structures
Yes.
and how they radiate outwards. I think that what's so cool about the oral microbiome and the oral biofilm is that huge gradient that you see between you can have both a strict anaerobe and like an aerobe very, very, very close, like on the same tooth, just at different points in this like beautiful complex structure. So I think of organisms that are their role both, you know, like what properties they uniquely have, but then just like how they play a role in the community, I think is extremely important. And I think, you know, to me, it's a better framework for health and disease. It's like they're not just little organisms just like hanging out by themselves. They truly are a community the same way you think of, you know, any food web anywhere in the world. You could be in a rainforest, a desert, or on your incisor, you know? So I think F nucleatum is a pretty cool, just its role in helping like as a community builder almost. Also, from a culturing perspective, it's much easier to grow than my other friends.
Than almost everything else. Yeah. Good Lord. You work on treponema, so that must take eons.
Yes. Yeah. They grow much better together though. So when they're in a co-culture, it's frustrating when I'm trying to get the individual cultures to pool them before they're all struggling. As soon as I pool them, they're like, let's go.
That's so frustrating. Yeah, I know the drill. The F nucleatum story with colon cancer, how do you feel about, I know you had already mentioned that if it's in the wrong place, doing the wrong thing, obviously, but do you think there's a strain variation that we could hone in on for that story?
Yes.
Yeah.
I think that there's a strain variation. I think there's difference in virulence in a way in the oral space that we just don't have access to that information as of yet because sexiness is informative of who is there on a very broad spectrum. I like describe it to my friends. It's like you go to the supermarket and you pick up apple, but I want to know if I'm getting a Red Delicious or a Granny Smith because that will be very different.
No, you want a Cosmic Crisp. It's a Cosmic Crisp you want.
Strong opinions about apples.
I'm from Washington.
Valid then, very valid. Cosmic Crisp. I'll have to give it a go. But yeah, I think that there's just a missing piece of information of like what's going on a strain level or like what virulence factors are being expressed by certain bugs. That kind of, you know, that's kind of one of my hypotheses with my second project, like what causes, because we do know some people respond to treatment really well. There's like obviously a multitude of factors, but I do think having a better understanding of what is actually going on and who, you know, Cosmic Crisp or Red Delicious is, you know, there. So I think for F nucleatum, for any of the, you know, other kind of big players in periodontal disease, I think it's important to know, you know, what exactly are we looking at? Who are we dealing with right now?
Right.
And well, that would be helpful
context
to know.
matters.
Yeah. Yes. Yeah.
So if the environment is also going to be a big player, so we talked about the reciprocal relationship of inflammation, and I think that, you know, that remains true, but it gets complicated. And again, for us, we are able to kind of dig in and delineate these attributes. But one of the studies that I really liked being a part of was the split mouth induced gingivitis study, where we induced disease on one quadrant but you could see a trend for disease on the opposing side, meaning that you've changed the environment. Obviously, the bugs in your mouth, while they are very niche to their localized moment, being on the incisor or what have you, but on the contralateral side, you are getting an inflammatory response on one side. It's going systemic because your gingival tissues are highly vascularized. And so you are getting an uptick in inflammation in that moment that does feed the contralateral side, such that when you get bacterial contamination from we'll call it the infected side, or the side with pathology that we've induced gingivitis in, those bacteria are now able to colonize and do the wrong thing because they have the right food, because the inflammation is there. So it's you start to see that rise of pathology and dysbiosis, but it's slower because it's not as concentrated. The side with pathology that we've induced gingivitis in, those bacteria are now able to colonize and do the wrong thing because they have the right food, because the inflammation is there. So it's you start to see that rise of pathology and dysbiosis, but it's slower because it's not as concentrated. But that systemic component is, feeding all of our tissues. And my other favorite study is Glogauer's 2-hit model, where he's basically using an animal model to show that if you give a mouse periodontal disease by ligature, and at the same time you give peritonitis, which is gut inflammation, you get a much more exacerbated pathology in either area. So your perio is worse than just perio alone, and your peritonitis gut inflammation is worse than if you just had gut and no perio. So like that inflammation component is key. And I think that all of us can agree that we're under stressful environments, maybe not eating the right things. And, we have a low level of inflammation, kind of always battling, and how to minimize those inflammatory moments is really key. But to not forget, I know that, I talk to a lot of hygienists that get frustrated with people who they feel like they got under control, but then they'll come back, a few months later, and it's just like they never did anything. And we have to be mindful of the rest of the body, like you said in the beginning.
Yeah, I think the inflammation and systemic inflammation, and really understanding that, it's kind of like setting up the environment in your mouth. Because if I think of like the microorganisms that live in our mouth as I think of like a rainforest or something. You have all these organisms, but then you also have like a really complex soil and like trees. So you have to think of like, the birds and the panthers, but then also you have to think about the soil environment. So the more you think about it, the more it just becomes so much more complex. But I just think that, it's important to understand it from both perspectives. Like, it's clearly not just like a single infection, a bug wreaking havoc. Like, there's, as I'm sure you all are so familiar, there's papers where you can't give a mouse periodontitis with P. gingivalis alone. Like in a germ-free mouse, it's not doing anything. It doesn't, it needs the community. So I just think it's really important that the understanding of periodontitis is it, even if you don't completely understand it, just to understand that it is complex, that it has all of these factors. And I think that approaches that attack it from all different angles are important, knowing that it's like such a, one of the top 10 health concerns from the World Health Organization. So, like it's affecting many, many people. And I think if you get, too lost in the details, whether it's from the microbiology side or from the immunology side, you miss the point that it's like, we need to improve human health, and we need to kind of look at everything simultaneously.
Absolutely. So what are you going to do when you get your PhD? What's next for you?
So I'm planning on doing a postdoc. I don't know where. This just has been my, I feel like as we talked about at the very beginning, the wave of grad school of I'm never going to finish. Oh, I think I am. Oh, just kidding. Do I like science? Do I ever want to touch a biped again?
Yep. Yep.
The, like this is the last time I will smell Gucci.
Oh God, I know that.
But yeah, but I think especially with these like clinical samples that there's just so much there. I feel very excited and very driven to just keep pushing this story forward. Um, I think it's really important to kind of keep that balance of microbiology and immunology, like not to get lost too deep in either one. So I would love to keep studying what I'm studying, but just, push it even further in a postdoc. So that's the plan as of now. I think I would love for the field of oral microbiology to be on par with, when we think of gut microbiome. Like I want someone to hear the word microbiome and then have to question which
Yeah.
one are we talking about? Because if you say microbiome, people say gut. Yeah. So I would love that. And I would, and for people to just have, I think it's just important for a better, community, global understanding of our health. And I think that when you understand like the microbiology aspect, it's really cool. And so there's like, so I think that if there's, I would love to be able to push the field forward and just increase public knowledge of one, why they should floss, two, maybe one, how cool it is, two, why we all should be flossing.
Agreed.
Yeah.
I couldn't agree more.
Yes.
Where do you want to live for your postdoc? And what do you want to go back to remineralization? You're pretty happy in periodontal. Do you want to move on to a different microbiome?
I think I definitely want to stay in the microbiome space. I think I would like to stay in the field of oral microbiology. I think maybe shift it maybe a little bit more towards the immunology because my PhD has been it's mainly microbiology with like a little bit of sprinkle of immunology. And I would kind of maybe like to get a little bit more balance. But with all of this data that I'm collecting from these clinical samples, I'm just going to have like mountains of DNA and RNA sequencing analysis. So, okay. Yeah, I think I'd love to stay in the field of oral microbiome. And I think periodontal health or periodontal disease around the gums, I think is where I like to stay. Cavities are very interesting, but I think the fact that your gums are, basically gateways to your bloodstream and their systemic effects, I think is just really, really
excellent. Well, I'll put the word out and see if we can drum up something fun for you. That would be amazing. I want to see you go far with this, mainly because I'm no longer at the bench and I want to see somebody.
We will live for you, Margaux.
Yeah.
Very cool. I'm excited for you and so excited to see where your research goes.
Thank you. I'm excited as well.
You never said where you want to live next. You want to stay in the California?
Oh, I think so. That part is also, I'm not sure. California has some great, there's some great schools over here. I think I would be down to, I think it really depends. I go between like where would be cool to live and then like what would be the best thing for my future as a scientist. And I would ideally like for those two things to be in line. I think I'm more interested within the U.S. on coastal.
I definitely got really interested in somebody who was in Lubbock, Texas, and I was like, I have to rule that out because it's Lubbock.
Yeah. Yeah, I can't. I'm a water baby. I need
same.
I need the ocean or I need water in some capacity.
Yeah. Mm-hmm. Shut your mouth. You were in Jersey with me.
Hey, hey, still technically had access to water. It's just
Yeah,
different.
it's true. Right. Well, this has been great. Thank you so much for coming on to Let's Get Oral with us. This is fantastic. I'm so excited.
Yeah, thanks for having me again. It's been great. It's nice to talk to people who, understand my love and obsession with the oral cavity.
Oh, we're family now.
Yeah.
Welcome to the family.
Right on.
It's a small family, but we enjoy it. I think we both kind of want to be at the bench too, but not enough to suffer the paycheck.